Hi guys, welcome back to the channel. Hope y'all are doing well. Today I want to talk about how to become a backend engineer in 2022. We're going to start with some beginner concepts and then go all the way to more advanced topics that you want to know as a backend engineer. The guide is going to be very comprehensive, so I'm going to put timestamps in the video so that you can move around freely. I would highly recommend taking notes or just saving the video to watch later on, just because of the sheer amount of content that's going to be there in this one video. With that being said, let's get started. Step 1 is learning the language of your choice. It does not really matter what programming language you choose to learn first. What matters is how much you learn about that one programming language. Some good examples of backend languages are Python, Go, and Java. So you can pick any one of them and dig deep into it rather than jumping around different languages and not learning too much. So what are the different things you want to learn in a programming language? So for starters, you want to know the fundamental concepts like conditionals, loops, and functions. You also want to learn about the different data structure like set, map, list, tree, and graph. Also, you want to know about how these data structures are used in practice. Almost any application you come across in the internet uses these data structures, so it's very important to know how you're using them rather than only how to implement them in code. Some of the project ideas that I have for step 1 would be go ahead, learn the fundamentals and the data structures, and then come up with some text-based applications like a calculator, stopwatch, currency converter, dictionary, or budgeting. This is going to let you focus on the programming language itself rather than the app idea. Step 2 is going to be learning about basic client-server relationship. In web development, it's very important to know how the full picture works. You want to know how the client works and the server works, and then you want to know how the two work together to present different web applications to end users. As a backend engineer, you want to know in a web application, where does backend exactly fit? Because some of the work the web application does is going to be on the client, and some of them is going to be on the server. So your job as a backend engineer is going to be to focus more on the server side of things. You want to know the fundamentals of HTTP. What is the different protocols that are out there? What are the specifications of HTTP? You want to know about the request response cycle. So when you hit enter in your browser and the browser talks to the server, how does this request response work and who does which part of this cycle? You also want to know about different status codes. As a backend engineer, it's very important for you to know which status code to send to the front end on which scenario. So there are a bunch of them, but the very common ones are the 200s, the 400s, the 500s. So you want to know when to send them, what do each of them mean, and what are the small subtleties amongst the different ones. So once you gather the idea of how a client server works, there are some project ideas that I would recommend. The first one is to trace the path of a web request from a client's browser all the way to the server and back. So you can literally go to like google.com and then inspect or literally note down what you think is happening when you hit enter and until google.com is actually there in your browser. Because a lot of things go on between you hitting enter and you seeing the page. You want to also know how to use the network tab in Google Chrome. It's very important to know how the network tab works because you can know a lot about the back end of a web application just from looking at the network tab. So I would recommend making yourself familiar with how the network tab works and trying to see different information you can get from the network tab. While you're doing that, I would recommend just keeping your eye out for a few details like the request, response headers, and body. You want to know about the different HTTP methods like GET, put and post, as well as the status codes. And you want to know about the cookies and how the browser can have cookies and how they're sending it to the server. All these are gonna give you the idea of how, in a bigger picture, a full stack web application works. All right, step 3 is gonna be a simple database. So you want to learn your first database. I would recommend going with the MySQL or Postgres. Both are very common relational databases. I would say they are way more common than the other more complicated NoSQL databases. So go ahead and learn how to use MySQL or Postgres. Learn the SQL programming language. This is the language you use to query your data from a relational database. While you're learning SQL, I would recommend looking at the basic constructs like create, insert, select, where, and join. It's very important to know how the basics work, because no matter what app you design, you are gonna have a database and you will need to query the data in that database. Once you know the fundamentals of the database, I would like you to go into the details a bit more to know exactly how the database is working. So for relational database like MySQL and Postgres, you want to dig deeper and see how exactly is your data being stored in the database. You want to learn about the primary and secondary indexes of your database. Look at the trade-offs you make by creating more and more index. You want to know how the indexes are being stored in disk, because everything is a trade-off in a database. So just because you can create more and more index doesn't mean your database performance is going to be the best. You want to learn about why the data is stored in disk. Why can't you just store it in memory? The difference between disk and memory. What happens if your data is in disk as opposed to in memory? Once you do those, you should be good with the basics of a database. So you can go ahead and do some projects to kind of emphasize on the skills you learned. What I would recommend is create a mock employee database and create some tables, insert some mock data, and play around with different queries. Alternatively, or alongside the first one, you can import some dataset from a website called Kaggle, which has a bunch of data about literally any kind of thing. You can download them, it's usually in a CSV file, ingest them into a SQL database, and then play around with different queries. That's a very, very good way to learn about SQL too. Step 4 is gonna be to learn a backend web framework. There are a bunch of backend web frameworks that are out there. Depending on your programming language that you choose, you can pick any. For Python, the common ones are Flask and Django. There is also Fast API, which is very simple. For Golang, there is Gin and Echo. For Java, there's Spring and Hibernate. It doesn't really matter, just pick one web framework and see how a web framework works. What essentially a backend web framework is going to do for you is abstract away a lot of the more detailed understanding of how client server works, and it's going to let you work with a much higher level API, which makes things much easier. Once you learn how the framework works, this is your time to build your first CRUD API. CRUD is create, read, update, and delete. This is the most basic form of an API. So go ahead and use the knowledge you have of your new backend framework and create a complete CRUD API with the language that you chose and the relational database that you learned in step 2. Step 5. Now that you know how to build a very simple API, you want to know about some of the design principles that a simple API should have. So you want to learn about what a REST API is. So REST is a particular kind of specification for APIs. Most of the APIs you find in the web is going to be REST API. So you want to know what makes an API a REST API and how does it work. You also want to know about GraphQL. This is another kind of API like REST, but the fundamental idea of a GraphQL API is very different from a REST API. So you want to learn about both of them. Once you learn about both of them, you want to kind of put them beside each other, look at their differences, and see what trade-offs you make by choosing REST or GraphQL. You want to look into a specification called OpenAPI. This is a pretty common specification out there that you can use. It's going to tell you what's a good way to write an API, what status codes you should use, what should be the format of the API when it comes to the request body and the response body. And it lets you do everything in a very presentable way so that people that are using your API have a very easy time knowing how to use it. Once you go over them, time to do some projects. The first one is, now that you have some knowledge about a good API design, go ahead and create a proper API with multiple resources. Use OpenAPI specification for easy discovery and navigation of your API. Alright, so now you should have a good amount of knowledge of a good, simple API design. So let's take a look at some of the more advanced concepts when it comes to API design. The first one you want to know about is rate limiting and how rate limiting works. I'm pretty sure if you have looked at API endpoints or APIs in the internet, a lot of them are going to come with rate limiting. Essentially what rate limiting does is it stops users from abusing the website, the API. So they put a limit on how many times you can call the API in a set amount of time. Go ahead and learn about how API authentications work. Almost all the APIs that you see online are gonna need some kind of an authentication. There are multiple ways you can authenticate a user when a user is using your API. So go ahead and read up on them and see how the different ones work. You should also know how to use tools like Swagger and Postman. Both of these tools are very critical in web development, especially API development, so you want to know how to use them, and they're going to make your life significantly easier when writing and developing endpoints and APIs. Alright, so project ideas for this section. The API that you designed in the last step, go ahead and implement some rate limit on different endpoints within this API. And an amazing way to learn about how to design good APIs is to look at existing APIs by other companies. Namely, some of them I have here are Stripe, Twitter, Yelp, and Google Maps. All of them have very good documentation on their APIs. So go ahead and take a look at how they designed them, what rate limit they have, what kind of authentication mechanisms they're using, and overall how to document an API. Because the most important thing of an API is the users of your API should have a very easy time using it. That's when you know you have a really good API. Alright, so now that we have gone over the basics of more like database and then web framework, so let's look at some of the more system metrics. So step 7 is going to be system health. So to know that your API is working correctly, and not even API, just overall how your backend is performing, you want to know about a few metrics that tell you about the health. Some of them are latencies and response times. These are very important to know what each of the term means and how can you read the numbers when you're looking at them. You want to know about your CPU and RAM metrics that you want to monitor when your backend is being used. Just from looking at the different CPU usage or RAM usage, you can tell how to optimize your backend how you can optimize your backend better. Know the difference between CPU bound and IO bound tasks. They are very different. They put different kinds of stress on your computer. So you want to know what kind of task is CPU bound, what kind of task is IO bound. When it comes to databases, you want to know about disk seek times. That is the most expensive part of a database query. So you want to know what that exactly means and how it works. When it comes to caches, I'm going to come to caching later on, but you want to know metrics like what's your cache hit or cache miss rate. This is going to tell you how well your caches are performing and how can you optimize it better. That brings us to step 8, which is caching and how does it work. Learn about server caching. Caching is one of the best things you can do to optimize your backend. You don't want to be reading data from disk all the time. Disk reads are very expensive, so you want to maximize the use of caches. So go ahead and learn about server caching. Know why do you need caching? What exactly are you gaining by substituting a disk read with a cache read? You want to know about how databases and caches are different. Both are essentially storing data, but the manner in which they're storing and the reason that they're storing are very, very different. So you want to know about them. Some examples of server caches are Redis and Memcached. Feel free to look into one of them or both. I have videos for both of them in the channel. You can take a look at them, but they're going to be a very good starting point for you to know how caching works. Project ideas. Very easy. You have if you followed the previous steps, you have a proper API with a bunch of endpoints that have rate limiting and database in them. Go ahead and implement caching in your API. So instead of fetching data from your database, fetch it from a cache now. And then compare the two that you had, right? The one without cache and then the one with cache, and see how by adding a very basic layer of caching, you can significantly improve the performance of your API. That brings us to step 9, which is a bit more advanced, something called messaging systems. So messaging systems are used for asynchronous communication. So let's say tasks like uploading an image or sending an email or sending a notification. These are usually done asynchronously. So when a client hits your backend endpoint, you don't really have to do them exactly immediately. You can let some other process take care of it. That's called asynchronous communication, and you want to know about how it works and why use it. Yeah, exactly. So you want to know why do you exactly need asynchronous communication, because not all tasks should be asynchronous. Similarly, not all tasks should be synchronous. Some good examples of messaging systems are Kafka and RabbitMQ. So take a look at them, look at some blog posts to see how they're used by different companies. The most important thing about a messaging system is you need to know what kind of tasks are good for asynchronous communication. So you can't just make everything asynchronous. That's not how it works. You want to know which tasks exactly can be asynchronous and how can you actually make it asynchronous using things like Kafka and RabbitMQ. Project idea. So now that you know about a messaging system, go ahead and implement some asynchronous communication in one of your API endpoint. Try to implement an endpoint that will take in a request and then kick off some kind of an asynchronous task using Kafka or RabbitMQ. For instance, you can have an endpoint, let's say it's called send email, and when the client hits that endpoint, you want to kick off an asynchronous task using a RabbitMQ or Kafka to send that email out. You don't want your endpoint to do it because what's gonna happen is your endpoint is gonna take a while to get back to the client if it is responsible for sending that email out. And then go ahead and brainstorm tasks you can think of that are perfectly suited for async communication. As I said before, not all tasks can be async, so you want to know what kind of tasks are good for a messaging system. So if you have made it this far, now you know how to build a basic and robust backend API. Your API has a good database backing it. You have things like rate limiting, caching. You also have more asynchronous things like messaging systems. So at this point, you should know how to build a very basic but very robust endpoint. So every slide from now on is going to be a bit on the more advanced side. With step 10, you want to know how to build scalable systems. Read up on scalable system building. Most of the large scale apps like the Uber, the Yelp, the Google, the Facebook, they have tons and tons of blog posts on how you can build scalable apps. These are usually very high level, but reading them would kind of give you an idea on how different technologies are combined for scalable app building. 2 books that I would highly recommend to learn about system design is System Design Interview, that's for beginners, and for more advanced, you want to read Designing Data Intensive Applications. Both are amazing books, amazing to know about how system design works, whether you're a beginner or you want more advanced knowledge. The next thing you can do is look at some of the existing apps that are out there. Look at the Twitter, the Facebook, the Uber. You know, like how they work, right? Like take a look at their function and then take a step back and you put on the engineer's hat and design the API that an app like that should have. Choose the database that a Uber should have, that a Twitter should have. This is going to be a very, very basic exercise because, of course, in an app like that, you have tons and tons of technologies involved. But take a more basic approach. Design a simple API for a Uber. Design the databases that you want to store your data in. Once you choose the database, design the data models and schemas to kind of give you an idea of how large-scale apps should be built. Once you go through the books, you go through the blogs, and you do that little exercise, you should have some idea, but still you need to know more about the fundamentals about system design, which is our step 11. That is, know some of the fundamentals. The first fundamental is, I would say, is load balancer. Very critical in designing a scalable app. So take a look at how load balancers work. Similarly, reverse proxy, very important concept to know. You want to know about horizontal and vertical scaling, because whenever you have a large scale app, you want to be able to scale up and then scale down. You want to know how it works, so both horizontal and vertical scaling. You want to know about database change data capture, or CDC. This is very important. Essentially what this is whenever a piece of data changes in your database, there is a stream of data that you can follow to know how exactly did your data change. I have a slide, I think a few slides later, which is gonna dig deeper, but take a look at what exactly CDC means and how does it work. Know about centralized and decentralized databases. Centralized databases are databases like MySQL or Postgres. Decentralized ones are ones like Cassandra, which are more decentralized, right? So take a look at different examples and look at the trade-offs you make by picking a centralized or a decentralized database. Now, step 12, which is Microservice Architecture. The de facto industry standard right now is to have a more microservice architecture for any large-scale web application. So you want to know what exactly this means. So go ahead and learn about how a microservice architecture works. What is it? How is it different from a more traditional monolithic application? You want to know about the different communications that happen in a microservice, because essentially in a microservice architecture, you will have multiple independent services responsible for different things. However, they would need to communicate with each other. For that, you need different communication protocols. So go ahead and see how the different communications happen. You want to know what exactly is a timeout and how does timeouts work. When microservice A is talking to microservice B, if A cannot reach B, after a certain time, it should just give up. That's where a timeout comes in. Take a look at that and how it works. You want to know about different load balancing algorithms. Let's say if you have one microservice and you have 10 instances of it, you want to know when a request comes in, which one of the 10 instances should you forward your request to. There are a bunch of algorithms for it. Take a look at the different algorithms and see how one compares against the other. You want to know about synchronous and asynchronous communication. Microservices can communicate with each other synchronously, like through an HTTP call, or it can happen asynchronously through like Kafka or some other messaging system. Similar to timeouts, you want to know about retry mechanisms. In the instance I explained before, where A is trying to communicate with B, what happens if B is not responding? Should it just give up? Should it try a couple of times? If it does try, how many times should it try? Should it just keep on trying or every 2 seconds? Or should it just like try 2 seconds later and then give it a few more seconds and then try it again? There are a lot of subtleties to it, so take a look at how retry mechanisms work. All right, so this was a big one. The project ideas are going to be pretty large here. The first one is, actually this is one whole idea, so I'll go through step by step. So look at a large scale app right now. Take your Uber, take your Lyft, Twitter, Facebook, whichever, right? And then design the microservices for that app. Imagine what kind of microservices an app like this should have, and then design them. Think about how the different microservices should be communicating with each other. Should they all be synchronous through HTTP calls? Or should there be more asynchronous communications using Kafka? Go ahead and literally write that down. For every microservice that you came up with, design the API endpoints that you think the service should have. Similarly, every microservice should have some kind of a database backing it. Go ahead and design the database. Take a look at the different trade-offs by choosing a relational database or a non-relational database. Take a look at the queries, take a look at the schema, design all of them. Which brings us to step 13, which is the advanced side of databases. So by now you should know a MySQL or a Postgres. So go ahead and expand your knowledge about databases, right? Go ahead and learn about non-relational databases. Examples are Cassandra, MongoDB, but there are tons of them out there. So pick one, pick two, and then learn about them. Take a look at why exactly do you need non-relational databases? Because non-relational databases, just because they're new, doesn't mean they solve everything, right? They come with trade-offs. There are certain tasks that you want to use a relational database for, and there are certain tasks you want to use a non-relational database for. Take a look at the difference, compare the trade-offs. Learn about the more niche databases like a time series database, QuestDB, time series DB. These are some examples of a time series database. There are other niche databases like a graph database. Look at Neo4j. That's a pretty common graph database. By looking at all these different databases, from relational to non-relational to more niche ones like a time series or a graph, you're going to expand your horizon on what databases can do, and you're going to be more well positioned to make an educated call on which database to use for your application. No one database has all pros and no cons. Every database comes with pros and cons, right? So you want to know about them so that when the time comes for you to pick a database, you know exactly which one you need for your use case. The project idea for this is going to be most probably in the first step, you created an API endpoint which was backed by a relational MySQL or Postgres. So go ahead and create a new API, but this time instead of using a MySQL database, go ahead and use a MongoDB or a Cassandra. And then think of an app idea and design the data models in different databases. Which ones would you pick? what are the trade-offs. So let's say you think of a food ordering app, right? For this food ordering app, go ahead and pick like 5 databases and then think through how using each of the different database is going to be different for that same app, right? This is going to show you that amongst the 5-6 databases, not all of them are well designed for the kind of data you want to model. That's what you want to know. There are a bunch of databases out there, but you want to know how to pick by comparing them. So go ahead and do that. Another one I would recommend is to download some large dataset from the internet and then populate some of these databases with those data. Then do some simple queries and compare the performance across different databases for the same data. So you can go to kaggle.com or some other website and download a dataset with millions of rows of data, right? Take those millions of rows of data and insert them into, let's say, a MySQL, a Postgres, a Cassandra, a MongoDB, and a QuestDB. So now you have like 5 databases with the same data. And now run very simple queries like getting top X or getting some rows by doing some basic filtering. Do those simple queries in your different databases and see how for the same data, different databases can perform differently. All right, so with step 13 done, step 14 is going to be more data focused. So let's take a look at what you might call it a data engineer, but any backend engineer should know about these more data specific concepts. So the first one is learn about data infrastructures. At a company, data is usually one of the most important things. So it's not like the apps you design where you have one database with one set of data. Usually in a big company, there are very complex data infrastructure where the same piece of data is replicated across different databases. Some are augmented with other information, some are denormalized, some are normalized. So data infrastructure tends to be very complicated in a large organization. So you want to know how what different concepts are out there. So you want to know how exactly does an organization use data. At any given company, data tends to be the most important thing. Every decision you make in the company is based on the data that the company has. So you want to know how exactly does the organization use data, because the data is not only used to present things in the UI for the user, the data is used for different machine learning algorithms, different computer vision algorithms. The same data is used for experiments, right? And even like product folks are going to use the data to make different product decisions. So your data is very important, and you want to know how in a big organization the data is utilized in multiple different ways. One very key thing at a large company or any company nowadays is how does data move within an organization? What you might be more used to is call an API endpoint. The API endpoint writes the data to a MySQL database or a MongoDB, and that's the end. But that's not exactly how it works. Once the data is written into a more traditional OLTP database, like a MySQL or a MongoDB, that data usually moves throughout the organization, right? Different teams care about that data. Different teams want the same data in their own databases. Or you will have teams that want to augment that data with other information and then store them in a different database. So the data is usually flowing within the organization, and you want to know how exactly that works. That brings us to the next one, right? For the same data, you might have multiple databases. You might have one OLTP database, which you're using transactionally, and then you can have an analytics database for the same data. You can also have a time series database for the same data to make like time series oriented queries. So take a look at how can you use multiple databases for the same product. To do all the things I mentioned before, there are a bunch of technologies that are involved, so you need to learn about how they work. The first one I have is Apache Spark for ETL jobs. These are more batch-oriented jobs that happen periodically, so you might run a job every hour or every day, right? And Spark is a very common technology for that, so go ahead and take a look at how that works. For more streaming jobs that are happening in real time, so these are not happening periodically like Spark, these are happening in real time as data is moving through the organization. There are a bunch of technology like Kafka, Flink, and Beam, so take a look at how they work and read blog posts about different companies that talk about how they use these technologies. So as I mentioned before, that the data flowing within an organization is very important, and it's becoming more and more fundamental in any big or small company. So you want to know how to create a flowing data pipeline like this, and you can call it a data pipeline. And it's very common to create this pipeline with Kafka. So take a look at some blog posts or videos to see how different companies do this. So those are the more data-focused technologies, I would say. To recap, go ahead and learn about batch jobs like Spark, more streaming jobs like Kafka, Flink, and Beam, and then look at some videos and read some blog posts on how different companies create the data pipeline to have data flowing within the organizations, mostly with Kafka. That brings us to step 15, which is cloud computing. This is where the next generation of development is going to. Now, everything you do is going to involve some kind of a cloud technology. So to future-proof yourself and to work within the industry right now, you want to know what cloud computing is and how exactly does it fit in. So there are multiple cloud providers like AWS, GCP, DigitalOcean, Google Cloud, a bunch more, right? So go ahead and pick one, whichever. Everyone offers pretty much this very, very similar things. So go ahead and pick one and look at all the different things they offer, because they offer many different things, right? From databases to compute engines to application-specific stuff. So take a look at them, what they offer and how they work. Look into cloud functions like AWS Lambda. More and more as time goes, people are moving towards a Lambda architecture where they only pay when they use something. It's not like they have a machine and as long as the machine is turned on, they're paying. Instead, they pay by usage. So only when their things are being used on Lambda, that's when they pay. So very common. A lot of companies are moving to Lambda for a lot of their more critical things and more expensive things. So you want to know how Lambda works and how it fits in and compares to more traditional deployments. Yep, similar to what I said before, look into serverless function, which is exactly what AWS Lambda is. So take a look at how serverless works and what are the different infrastructure you need to make it work. Apart from serverless, there are a bunch of other offerings, especially from AWS. One of them is SNS and SQS. All of these are different messaging services, different queuing systems. You also have different databases like DynamoDB and S3, both of which are very common AWS databases. So go ahead and see how they work, right? A lot of development in the next few years are going to be in the cloud. So you want to be familiar with different cloud offerings as a backend engineer. So I think that's all I had for y'all here. So 15 steps, if I recall correctly. Yep, 15 steps. The first 5 or 6 are more basic for you to get started. The next one are more advanced. So pick whichever ones you want. It should be of great help to you. Let me know if you have any questions in the comments. I'm going to go ahead and put some timestamps on the video because I know it's a very long one, but feel free to put in the comments anything else you want to know, and I'll get back to you as soon as I can. So with that being said, hopefully this was helpful. Let me know if you have any questions, and I'll catch you all in the next one. Bye-bye.